Welcome to our third part of our lecture video series from Friday, March 10th, where we talk about the formation of our pi molecular orbitals. So just like we had our sigma molecular orbitals being formed by linear combinations of head-on style additions of atomic orbitals, we will now look at how the pi molecular orbitals are formed. And as stated here, we see that pi molecular orbitals are formed from side-on combinations of our py and pz orbitals. So I can look at this example. Let's call these our py. And down here we have our constructive combination, and up here is our destructive combination, where our constructive combination has this side-on addition like so. That creates this kind of new shared shape with a planar node, meaning any space in this plane that kind of bisects these two orbitals is a region where we have no electron. And this is our bonding molecular orbital, because it is the result of our constructive side-on combination of our atomic orbital, here the py. Now the destructive combination, or the addition of the anti, is going to result in two planar nodes. So we have this planar node here, and also the one that's in the plane sticking in and out of the screen. So these are both nodes. And because this molecular orbital is the result of our destructive linear combination, this is our antibonding molecular orbital and is thus in higher energy than our bonding pi orbital. So if I wanted to be specific here, we could call this our py, so our pi py and our pi py star, pi star py. The only difference for the the pz, would be that the pz is something that is pointing in and out of the board. So it's just a rotation of this addition pattern. But now we're looking at our pz's. And if we were to add them like so, we would get a very similar shape to what is seen above, just again rotated in 3D space so that it is now oriented and pointing out and in of the board. And here now the planar node would be flipped and rotated, would be this plane. And let me fix our little geometry here, if that's any better, not quite sure. So this is our new planar node. And this forms our pi pz bonding MO. And if we were to look at the anti-addition or the subtraction, of our pz's, then we would see the exact same result as our py, just again rotated in 3D space. So we would have something like this, now kind of oriented flat. These are a little far apart. So something more akin to this, where we have our planar nodes existing in this plane, which is the one that bisects through these guys. And then we also have a node between them. That would be this plane sticking in and out of the board. So our two planar nodes. This would be our pi star PZ antibonding molecular orbital. And this would be at a higher energy state than the bonding molecular orbital. So in total, so here we got the constructive, and here we have the destructive. Since I have two different atomic orbitals that can combine in a side-on manner, I'm going to create 4 molecular orbitals because each of our side-on combinations have 2 different versions, being the constructive and destructive. So we have created 4 total molecular orbitals from our side-on combinations or side-on linear combinations of our py and pz orbitals. What we're going to see on Monday is a way to put all of this information together, like how we can energetically organize our sigma s star, sigma p star, and then our 2 different pi and pi star molecular orbitals, and how from that energetic organization we can place electrons in these molecular orbitals and get a more complete or more holistic idea of how bonding occurs in a molecule. So that's our plan for next week. We will wrap up bonding at the beginning of the week and then move into chemical reactions from there. So yeah, see you on Monday.